Hi, I'm Alex and this is my calculus project. The question I wanted to answer was, how can I use calculus to design precise artwork and eliminate paint waste? Mathematics and art are not often associated with each other because mathematics is logical and precise, whereas art requires divergent thinking and creativity. However, I figured I could use calculus to calculate the volume of paint needed to fill various areas that would make up a larger picture. By pouring a precise amount of paint that had been pre-calculated, the paint will not be wasted and I will achieve a smooth aesthetic. First step, I had to outline my picture. I just did a rough sketch of a mountain scene because Central Oregon, and keeping in mind that I would have to fit these lines to an equation later in order to integrate. Step 2 was to draw the equations onto a piece of graph paper using the outline. So I translated the lines onto graph paper as a known kind of function, and I used really convenient points because I knew I would have to write the equations later. Then I used transformational graphing rules and parent functions and just calculations to write the equations because I would need to integrate them in order to find the area under each curve. In order to write the equations, I wrote some linear, cubic, quartic, sine, and circle equations. Linear equations are pretty straightforward, just the y equals mxb form, or the point slope form. And cubic functions, I just use transformational graphing rules. For the quartic function, it was a lot harder to use transformational graphing rules because the A, B, C, and D shifting values would be very complex decimals, so I used my graphing calculator to input points and then it gave me the shifts I needed. Then I created the sine wave using the transformational graphing rules, and I used the circle equation to create the circles, so x minus h squared plus y minus k squared equals r squared, where hk is the center and r is the radius. And these are all the equations I wrote. Next, I needed to use integration to find the area of paint under all the curves I had just created. So I split up each area into different sections where different equations would be on the top or bottom, and then I integrated subtracting the top equation from the bottom equation in order to get the area, and then I would add up all the areas of the sections and get the total shape that I wanted. So you can see here I did a lot of integration. And then on sections 15 and 21, there were areas that were bounded by like a large portion of circle, which is not a function, so integration in terms of x was not going to work. I tried integrating in terms of y, but for some reason the calculator just did not want to do that, so I ended up having to use geometric shapes and finding their areas and getting a rough estimate of what the areas of 15 and 21 would be. Due to the sheer number of equations and the complexity of some equations, I didn't integrate everything by hand. I mostly used a graphing calculator, but here's the example of how I integrated by hand. Next, I had found all the areas, but I needed the volume of paint, so I multiplied each area by 0.2 centimeters of depth. That would give me centimeters cubed rather than centimeters squared. Then I decided I needed a container that would hold a precise amount of paint so that I could pour it into the various areas. So I created boxes, like cubes, of certain dimensions that I would need for each area. And in order to calculate the dimensions of each cube, I just took the cube root of every volume I found, and then used those dimensions to create a net, and then cut that net out, and folded it into a box, and then I had all of them. And here they are, and the process. boxes, I needed to actually create the framework for the artwork. So I used note cards in order to create the walls. I made indents in the surface of a board and then cut grooves along the note cards and inserted them and sealed them with glue in order to create the equations that I needed. The walls would ensure that the paint didn't spread to any other areas that I didn't want it to go, and it would fit exactly the areas that I had calculated of paint. So that's this. Now that I had everything set up, I was ready to pour paint. So I just took the boxes that I created and I poured different paints into them. So various greens or blues or purples, and then I just poured them into their designated areas. Then I let it dry for a day, and I removed all the walls, outlined the equations, and voila, I had a piece of artwork. Ultimately, I used calculus to create a painting of a mountain landscape, and I found how much of a particular color of paint would need to go in each area. Really, this form of art could be called mathematical printmaking because I have all the equations and I know how much paint I need in each area, so I could create this painting as many times as I wanted as long as I had the time and energy to set it all up. Involving calculus in the artistic process ultimately led to a really precise look to the piece, and because every drop I poured was pre-calculated, I didn't have any leftover paint in a palette that would just be wasted. When using calculus to dissect a piece of art could be very valuable for artists who are looking for that kind of precision or they're trying to conserve their paint. When it comes to painting, calculus and art can mix. Thanks for watching.